Alright guys, this is our agenda and we're gonna solve this problem, the gambling problem today. Okay, so first is asked to simulate throwing a dice, right? So what do we have? What do we have to use for that? Yeah, so random module, randint. What range? 1 to 6, right? So to simulate the 1 to 6 rolls. Okay. So all right, and then there's a game, right? So and then there's certain criteria listed here to select situations in the game. So why 12 is the losing one? Like, not losing one, sorry, winning one. Yeah. So basically, it gives you the lowest probability, right? One of the lowest probability, right? So because only 6 and 6 roll together gives you 12, right? No other. So both need to be rolled to 12. Okay. So so that's one of the reason. Um, so and then 8, we have many like more probability, like for example combination to get 8 is like 4 and 4 can give 8, 3 and 5, 6 and 2, right? So there are many combinations or many probabilities for 8, so that means you can actually pick that actually a losing bet. Okay. And then 11 kind of in between, so it's there for a lower amount of winning. And then for every other, so basically you are asked to, you need to ask for replay, right? So what is the input here? So there are two functions we need to write. For the second function, what is the input? uh, we are not, so not the improvement yet. Yeah, not the improvement yet. For the first function, there's no input, right? We just simulate that inside, right? So yeah, so bet is the input, right? All right, so let's write our plan for this. So okay, so so input is bet, and then the output is basically um, the call the game um, decision something. I think I have it some over here. Um, sorry, yeah, this gambling outcome is the one. Okay, all right, so gambling outcome is output. All right, so there are matches. Even the rock paper scissors one is a match. It's a match. Okay, so there are two plans now, right? Plan 1, so I'm gonna write it over here. 1, so it's over here. Actually, I'm gonna cut it and write it over here. So it's return a random number between 1 to 6. So plan 1, plan 2. Okay. So what's the input for this one? Input is bet, right? Input bet. What should be the step 2? So we'll have to basically roll twice, right? So in reality, basically you can throw two dice together, right? But in this class we cannot do it that way, right? So that's basically involve parallel programming, right? But it's okay, right? We can throw one after the other, which is also fine. Okay, but in fact, yeah, Python is capable of parallel processing, but it's actually a advanced topic that usually we learn in probably in a senior year of a college or maybe graduate studies. Okay, so but you can do, like, throw two throws one after the other and then sum up. Okay, that's what we're going to do. Okay, so basically um, throw two dices and get the combined value. All right. So 3. So now we have, basically we need to implement this code, right? So there are a bunch of conditionals and we just need to implement them. And you can see that they all start if, and you can actually use if or elif as well. Okay. All right. So first one is the winning, right? So if, so I should have sort of right here. Step 3 is if, right? Combined value. So I'm gonna say combined value, um, combined rolled value, right? Right. Value is equal to 12, right? So what do we have to return? What are we returning? 3.1. Return. Yeah, 10 times bit, right? Yeah. Okay. So the next condition, right? Right here, if the combined roll value is 8, you lose, right? So I'm going to do that later. I'm going to add this one now, right? So I'm going to copy paste this and then change. So 4.1. So if the combined value is 11, so I'm going to use else if, guys, okay? Even though my problem statement says if and if and if, I can use else if here as well, okay? 11, then basically this should be 2 times bit, right? Okay. So the next one, so step 5 is 8, right? Basically, what should be the, oh, I should return, right? Return. What should I return for this one? 0, right? Because you lost, right? So, and last one, the else, basically you're gonna ask, you're gonna print, right? Not print, sorry, return, right? Play again or something like that, okay? Okay. So notice, right? I have everywhere else I am returning a number, right? But here I'm returning a string. In Python, this is totally okay from a function. But in other languages like Java and C++, you may not be, I mean, it's tricky to do that, right? Because those two languages are statically typed. That means you have to define upfront return type for the function as well, right? That's why, okay? But with Python being dynamically typed language, you can return any value from a function, okay? All right. So let's write this code, guys. Okay. So the first one is, so um, we're going to define the rolling, right? Roll dice. Okay. Doesn't have any inputs. Okay. Just the random modules. I think we need to import the module. Import random. Right. So basically, simulate um, dice roll. Cubic. Okay. And basically just return random dot rand int. What should be the range? 1 to 6. Okay. All right. Next function. Um, play play game, something like that, right? Play game. That's a bet, right? So bet is the input. So I would say, oops, place the dice rolling game for the bet. Okay. All right. Step 2, basically this, right? Throw 2 dices and get the combined value. Okay. So combined value is then, what we should have here. So we need to, yeah, twice, right? So should this work or not? No, it's not going to work, right? So it has to be two addition of 2 calls, right? So plus this again. Okay. All right. So you got that one. So now step 3. So there's a bunch of if conditions, right? So I'm gonna copy paste and change, guys. All right. So elif all right, return this, else return play again. Okay. All right. So let's call this for few values. All right. So I think 1000. Print. We have to print. Okay. So you got play again. So I'm gonna copy paste few more times. Okay. So and you can see that, like, the probability is low for winning, and we can see right here, right? Okay. All right. So to do the improvement, right? So we need to generalize this to make the shape to include the so now the you can see that this function right here is for only cubic dice, right? So you can think of, dice can be number of sides can be a variable too, right? Like for example, pyramid shape, and then I think the decahedron shape, so like a buckyball shape, football shape, right? Football has a certain shape, right? So that a kind of symmetric as well, right? So there's a thing called buckyball, the carbon 60 shape. That's also 3D. That means, like, so you can generalize further this function to, you know do it for any shape. Okay, so this now this function with regard in the context of number of side, this function is specialized one. So we call it specialization in software engineering. But generalization is a good thing so that your solution covers a variety of scenarios, right? So let's make that. So I'm gonna, so that has the input now, right? So dice 2 basically number of sides, right? And that goes in here as the parameter. Okay, all right. And also, guys, I didn't ask for this, but I'm going to make this to default to 6. Okay, so this is how you do it. So now if I don't pass this number of sides, the default value is going to take as 6. Okay, so let's quickly adapt that one to this one too. So play game 2, right? This is going to be second function call. I'm going to let it just take the number 6, so I didn't pass anything. So let's play this one also like couple of times. So play game 2, I would say 600. Oops. And few more. All right. There's a one win over here. See that? 10,000. Okay. So yeah. Okay. All right. So let's quickly go over the 5 questions. 4, yeah, 5 questions. So write 2 Python reserved words you used in your code. Reserved words. Yeah. So there's a whole bunch over here. Def, if, return, elif, right? All of them. Are a statement other than an assignment statement you used in your code. So statement other than assignment statement. This is a assignment statement, right? Oh, I said if. Oh, yeah. So this whole thing is a conditional statement. Yeah, it's a compound statement, but it can be one. But return is a one other than assignment, right? And also import is the other one. Okay, that's also a statement. Okay. So sorry, this one. Did I do it over here? Yeah. Okay. So write a Boolean expression you used in your code. So Anything over here? A Boolean expression? Yeah, all of these, right? So this one is one, right here is one, there are several, right? Right, a binary operator you used in your code and respect to operands. So it's a binary operator. So yeah, these are the two operands, right? Plus, if you take this one, these are the two operands, right? Okay. Write a formal parameter used in your function code and the respective actual parameter argument you use. So basically, the formal parameter is this one, right? Bit, yep. And here the actual parameter is 1000. Okay, all right. All right, that's it, guys. Any question on this one? All right, let's start our new lesson. So we have been anticipating on this for a while, right? Since week 4, we anticipated, I think week 4, yeah, this lesson, right? Kind of we made a good case ever since, right? But this is usually at the end of an intro class because iteration consider a little bit of an advanced topic. It's close to the end of the semester, but we realized like we needed this, right? So yeah, so here we are now. So we're gonna learn it actually. So um, let's uh, before we getting into looping in code, let's talk about real scenarios where we repeat things. Let's talk about a couple of um, real scenarios of when we repeat. Yes.
Like when you're washing the dishes, if you're scrubbing something and the food doesn't come off, you keep scrubbing it.
Okay.
Keep
Yep.
checking if the food is
That one. Yes. Anyone else? Real scenarios of repeat.
Well, the thing we just did, we get where we just keep on like trying again, again, again.
Okay. Yeah. Um, so more like more obvious examples. Can you think of more obvious example? I'm not saying that you are incorrect or anything. They are correct. Commuting. Yeah, I mean that's a routine, right? That's repeat, right? Here's an example from me. Say you go to the gym and you do push up until you get tired, because the task is really clear, right? One push up, two push up. So push up is the task that you repeat until you get tired. Or there are several ways to say this, right? You do push up while you are being not tired, okay? Or until you're tired, okay? Or as long as you are not tired, okay? Or you can say you are doing push up for 50 times. It's now distinct value. Um, so it's not uncertain anymore, like until or you tired or anything. You do a certain amount of time, okay? But all scenarios we repeated something, right? And in fact, this is iteration or idea of repetition is the one that where pretty much the computer beat us, right? So the for example, let's say you have a huge essay, and then you are looking for a word, right? So if we are doing it manually by our hand, we just basically end up reading the text until we find the word, right? So it takes time, basically because well, we are slow, right? So it's usually the speed is like for single task for the brain, it's 0.1 second, right? So that's the maximum speed we have. So and then we have to basically read through and find the word. Okay. But we know that, like, in the computer, if you have the paragraph in the computer, right, you can really easily in few nanoseconds you can find the word, right? So that's basically where still to date computer is pretty much beating the human speed. Okay. And then on top of that we have also AI now, right? So it now can think up to certain close level to the human brain. Okay. All right. So there's an example over here. So basically doing something based on the condition, and in this case the baby in the car is she is actually crying. So this actual real technique that some people try, right? So you basically um, until she get to sleep, you go around the block, right? So and then there's a condition to check whether she is sleeping or not at the very beginning, and if it is basically if she is still awake, that means the condition is true. So we go around and then check again in the next round, right? So and then if this check of awakeness is, if it is false, that means she's sleeping. Now we can go home, right? So it's a good example, like real example. And you can see that uh, we we break the repeating routing based on a condition, right? Okay. So and you can see that it's the notion of the while loop, like while we are the condition is true, we repeat, and then we exit when the condition become false. Okay. So loop is a program construct that repeatedly execute its statement. Okay, so we call the loop body. Okay, so that's block of statements that belongs to the loop. Okay, so we also call the loop block as well. Okay, so that single one block of iteration we call the iteration, single iteration of the loop. Okay, it's not just one line, there can be many lines that belong to the loop, right? So one single iteration of that is called an iteration. Okay, one single execution of that block is called an iteration. Okay. All right, can go to the next one, the while loop. So here is the syntax for the while loop. Okay, so it start off with the keyword while, and we have an expression, and then at the end we have colon. After the colon, next line we need to have at least one line after the colon that is indented by a single tab or four spaces, which is basically going to be the loop block. Okay, so and then notice the pattern, right? So this is a common pattern in Python uh, for many code blocks or compound statements. Okay, so if it is a function, we start with def, right? Then we have the function name in the end, and we have a colon, right? And then basically rest of the code that is indented by one tab, they all belong to the function, right? So in another way, function is the name set of code. So function name basically represent that code set of code belong to the function, right? So it's the function block basically that's the bunch of statement that belongs to the function. Okay, and the same for the if as well, right? So we start off with if, we have a boolean expression, and in the end we have a colon, and then the statements belong to the if block, right? So and it's a usual common pattern in Python. Okay, so you will see the same for the for loop. And there's another one called a with statement. We will not learn it in here. Okay, with statement. Yeah, and then try except statements. Okay, so that we will also not learn here. Okay, and then in the end we have statement that belong to the main program. Okay, main line. So um, outside the while block. Okay. All right. Um, so basically, the sentinel value is called is basically something that causes loop to end. So we call that kind of value sentinel value. Okay. So without that, and then probably we may get a infinite loop, right? So so let's just take a one example while loop, guys. Okay, so I'm gonna go over here and then all right. I'm going to create a random number. Okay, so let's say I'm going to import the random module, and number equals ran int. Let's say like between um, 20 and 30. Okay, so I'm gonna generate some while loop over here. So just say like 23 is a it's considered bad number, so I'm gonna say while. Okay, num not equals 23. Okay, print, say you are lucky. Okay, okay, all right. So and then notice, right, so while loop require a boolean expression. So that means basically anything you have after the while loop, Python will consider it its truth value. Okay, so basically it will actually what is this? Okay, so that's what happened over here, I guess. All right, at least let's try this one and this run. So not okay. Come on. Okay. Okay. Did we lose internet or something like? I just log in. So let's reload. No, it's not. Connect to runtime. All right, so let's do it over here in the Compile Explorer. Um, yeah, again, can do it right here. Yeah, this is the last one. So, all right, and you can see what happened.
Oh, you didn't update the number.
Yeah, so basically this is an infinite loop, right? Because I have the sentinel, which is 23, but the condition is basically always true. So it's not I generated a number. It happened to be not 23, so it's always true. Now it's actually runs an infinite loop. Okay, so this is a more actually common scenario. Sometimes it's actually a buggy scenario. Usually, right? It's a logical error. Basically, what happened? I don't have an escape mechanism to break the loop. That I don't have that situation, right? So, right, what do I should have then?
You should find another random number.
Yeah, I should find another random number, right? So basically reassign this something like that, right? Now it actually broke, right? So basically, so many like in a really common error scenario is we forget to do an update, right? So that while loop at one point uh, break out, like in the while loop condition, which is this one. It's the Boolean expression, and need to have something that actually become false. That expression become false. Some condition that become false, and then we forget that. So that's what we added. Now it's actually work. Okay. So prior scenario is called infinite loop, but sometimes we still need. There are scenarios in which we still need infinite loops. Let's talk about a little bit examples. Real world examples of infinite loops, practical examples. Well, you don't need to think of 100% like forever infinite kind of thing, but there you can consider them as infinite loops. Yes.
Like security at a bank, it's always checking if someone has broken in, and then
Okay.
that
Yeah.
infinitely check it.
More obvious ones, you are correct. I mean, how about color lights? It's a repetition, right? Usually power outage or your repairs, you stop it, but it usually runs forever, right? So it's a kind of same pattern. Sometimes they adjust based on the traffic conditions in like traffic heavy cities, but if it is not, it usually a single pattern repeats, right? Pacemakers in the heart need to run a loop because generate several pulses, right? And it's a repeat, right? All right. So yeah, so there are, right, few, but usually, yeah. And then if we properly don't update something that relevant to the while loop expression, then there's a possibility of infinite loop. Okay, so we just created one. Okay, all right. So we call this the loop while loop expression, and it's a Boolean expression. Okay, so once Python see while and Python basically read this one and this one, and then extract out the middle, which is the expression, and it's actually considered as a Boolean value. Okay, so it gets the truth value of it. All right. So then what is the sentinel value here? This code 23 is the sentinel value, okay? Because that is the value responsible for, you know, breaking the while loop flow into the main program flow, right? So basically breaking out from the loop. So let's go and so we talk about the infinite loops, okay? So let's do this one together, guys, okay? All right. So a while loop reads integers from input into variable input val. Write an expression that execute the while loop while input val is less than 1. Okay, so we have to update right here. So what should be the condition? Input val while it's basically it says over here while input val is less than -1, right? So less than -1. Okay. All right. So let's check. Okay. Some more examples. So let's do this one in Colab. Okay. So there are more examples. Oh, we can try now. Maybe Google is having. I don't know this. Yeah, so Google picked only when I teach
Yeah.
to do something like this. So I'm gonna input the sorry, not we don't so just set the number. Okay, so number equals, let's say 45 something. Might not work again. Oh, work now. All right. So and you can see that. So this we started off with number 10,045, and then if it is greater than 0, we are printing the 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 modulo of it, and then we reassign the number to um, the integer division value, right? So let's print the number here as well. Okay. All right. And you can see that the gradual decrease of the number, right? So and you can see that this is the exit point, right? Because we the next one basically less than 0. Okay. So let's not yeah. What I'm going to do is I'm going to actually add this over here, this step over here, and you will see now we actually see the 0 occurrence as well. Okay. All right. Even though this condition is greater than 0, there's one execution of, see that 0 becoming 0, right? Okay. The reason is when we come to the top, number is now 1, right? So greater than 0, right? So we actually executed these two lines now. Okay, that's why. Okay. And then depending on, see, there are some tricky situation, right? I brought the line to the, I basically um, brought into the front, right, of this, right? And now we are actually changing um, the in this case num, which is part of while loop condition, right? Before we do any execution of the rest, right? So when we do so, right, you can see that it's actually kind of, even though the loop condition is now false, it's execute that last iteration. Okay, so that's something. There are some tricky scenarios you may face depending on where you put this update part of the number. Okay, so of the condition. Okay, all right. Think I can put that thing now. Um, all right, there you go. It's working now. All right. Oh, it's 12, guys. Let's take our break. Okay. Oh, all right. I just published it. It's in module 10. So this is a short video, and I want to warn you. This is Java code. So yeah, it's a different language, but you will see. You'll get the point. Yeah. So it's basically explain how while loop works. That's yeah. Continue. So let's do the last challenge activity in here. Okay. So integer input number is read from input. Write a loop that iterates while input number not equal to 49, negative 49. In each iteration of the loop, do these two things, right? Output negative 49 not found yet. Read integer input number from input. Okay. So what should go in here? While input number is not equal to 49, right? So while input number is not equal, so this operator negative 49. And then we basically we're going to print right here, right? These two, right? So print this, right? And then we'll have to do this again, right? All right. So let's check this one out. Oh, there's a mistake. Not found yet.
You have a period outside of the
Really?
repetition.
Oh yeah. Okay. All right, check. Yeah. All right. So let's go to the next one. Counting. So these are this. I mean, it's covering like some scenarios in which we need while loops. So we can also use while loop to counting, right? So that's a really common application of them. Okay. And then it's there may be variants as well, right? So right here it was simple addition, right? But for here it's basically a subtraction, right? They're all kind of considered as counting. It can be another incremental operator like multiply, equal, okay. Right. So so that's factorial, or nothing can. Let's take this code and then run it in the. Oh no, it's not allowing us. All right, so let's do the this one as well, guys. The last challenge activity of it. So integer input number is read from input. Integer n is initialized with 34. Com complete the while loop to perform the following task at each iteration until n is less than input number. Okay. So output this, okay, and then decrease n by 2. Okay. So here print. So just one explanation mark. And then decrease n by 2. So n, what should be the code? Minus equals 2. All right. So and then what we have to do? That's it, right? Yeah. Okay. Let's see. I wanted to show you. I think I did. Let me open this. I did an example in the other class that I think it's good to discuss. Forgot though. Okay. That. Yes. No, not this one. Where is it? I can't point it anymore. Maybe it's right here. Okay. There's a good point that I discussed in the other class. I now forgot which one was. Um, uh, okay. can do it over here. Yeah. So yeah, right here. Okay. So we can actually so I'm gonna rerun this one, and you can see over here, right? So while number is greater than 0, right? So basically, so we need this condition, right? Okay. So instead, I'm gonna add one more code block. So copy. So what I'm going to do is I'm going to remove this part. Okay. All right. Leave it like that, and then this probably going to be a um, so it still worked, right? All right. Why? Because again, that the truth value thing, right? So number becomes 0 at one point, right? So it's actually now the condition it need, right? So the truth value is actually now false, and then it's blueprint. Sometimes this scenario applies to the condition as well. So you don't need to explicitly write the condition. The condition probably there um, in the variable itself, right? So so there are situations. So some people say this is the more elegant way to write it, right? Because it's probably going to save a few nanoseconds, right? Because we removed that comparison operator, right? So it's not there now, it's just checking the truth value of it, because otherwise Python check truth value as well as the entire expression. So Python end up evaluating the entire expression, right? So now it's up to only just checking the truth value, which could be efficient than that. Okay, that's probably why. All right. So in coding interview kind of things, you may jump to like think of like using something like this. That may think, okay, this is an elegant way of writing code. So it also shows you your awareness of the what actually the thing, and then you also know about this thing called truth value, right? So kind of way to showcase as well. Okay, just wanted to show you that as well. Okay, so let's do the last one. So we did this one, right? Or not yet? Yeah, we did it, right? Yeah. Okay. So let's go to learn some for loop. So this is from this one we're gonna end today. So we'll should be able to finish this module Thursday, guys. Okay. All right. So while loop, we did things until a condition become false, right? So it's kind of uncertain, right? So we probably don't know beforehand when it will end, right? So basically when the loop condition become false, that it's gonna end. Okay, but for loops on the other hand, basically we know it's certain amount of iteration we need to do, so we know that number how many. Okay, for example, I want to do 50 push-ups. So 50 is the number, right? So so that's number certain. So basically the for loop syntax is this, right? It start off with the for keyword, and we have this check, and this is a boolean expression. Okay, so this in operator basically check the membership. Okay, so what it's actually checking is that basically the content, this variable is in this container. Okay, so that's checking that. Okay, and then if it is there, then we actually execute the for loop body, and then in the end it move to the next value. So we call them iterators in coding. So basically it Python use an iterator to move to the next item in the container. Okay, so this way you can loop over any container in Python. So there are containers. We learn about strings, right? Strings, list, tuples, dictionaries is a container. We can we'll next week, sorry, Thursday we're gonna learn for loop as a container. Sorry, range as a container, right? So any container, and you can use this syntax to go execute um, up to the length of that container. Okay. Okay. So let's create this example. Okay. So what I'm going to do is I'm going to copy. There was a bunch of, yeah, I'm going to copy this text. Okay. I'm going to go over here and then create an example out of it. So this is like text equals this. Okay, and then text. I'm going to split this. How do you find words? Dot split, right? Split. Right. So this gives us words. If you print it, it's actually going to be a list. Right. It's a list of words in here. Right here. Okay. So I want to actually print these words top down, right? I can use a for loop, right? For word in words, right? Okay, and then print that word. Okay, that word. Okay, so it's a list of word, and I'm printing them from top to the bottom. Okay, okay. So that's a list example, right? So you can use a for loop to um, loop over letters in a string, right? So let's say um, um, say code equals programming, and you want to print the letters, right? So for characters in code, right, print them. So basically after the loop, we call this line loop header for both loops. If it's a while loop, we call a while loop header. This is a for loop, so we call for loop header. And after that, in for loop also, whatever the amount of code lines that belongs to the for loop should be indented, right? So this is basically, now this just we are printing something, and this can be anything, right? So so print chars, right? And you can see that like this. Okay, so similarly you can print key value pairs in a dictionary, right? And also tuple, right? Any container in Python. Okay, so you can print. You can loop over them and do something. Okay, all right. This one also we can do the last one together. All right. So this one is we are given a list, right? We'll have to complete the for loop. Okay. String new paint is read from input and assigned to the element at index 4 uh, of list paint list. Complete the for loop so that for each value in paint list, the value is output followed by chosen on the same line. Okay, so basically right here for, right, for what should be the loop condition? For value, right, in, right, in where? Paint list, right? We print this. I think that's all, right? Check. All right. Let's check a little bit about this. Um, yeah, let's check a little bit about this in operator, guys. Okay, so so I have code here, right? So that's also a Boolean operator. Okay, so print, right, letter C in code, and it's there, right? So this is a membership check. So basically the in operator is called membership operator or membership check operator. So basically if it is in there, it's oh, why it's actually, oh oh, okay, sorry, yeah. So I got confused with the code as the text. It's the actually variable name, right? So C is not in their programming, right? So it's actually false, right? Return false. So if we check something like P in code, so we'll get actually true. Okay, right? So you got true. Okay, so because P is in there in programming, right? So this operator is called membership check operator. And what type of operator is that also? Depending on the value it returned, it's a Boolean operator, right? So in also a Boolean operator in Python. So it also has the same precedent to all the 6 relational operators we learned so far as well. Okay, so in and the other set is in, not in, right? So you can write so basically similar action but reverse. If I put not in here and not in here, and you'll see the it's now reversed. Okay, so not in become false when it actually false, right? um, uh, when it's actually in there, not in become false. Okay, when it's actually not in there, not in operator become true. Okay, so it's the opposite of it. Okay. In a later day we'll learn the is operation, is operator. Okay, all right, and with that I think we did this one. Yeah, so let's go to our problem today. All right, I just published it. Okay, fish bus in loop. So this is an interview question actually. Okay, um, it's in module 10, guys. So the problem is basically you are given a number, and if you're gonna print fish if it is divisible by 3, bus if if it is divisible by 5, if it's bus, if it is divisible by both, and not divisible bus if it's not divisible by. And then later as the improvement, so you'll have another, you have to write another function to do this. So I'm going to pick a random number, and then it's going to be, I mean, looks like it's going to be a while loop, right? So range. Oh, by the way, how do we, so what are other vocabulary word for while loop? Okay, so while itself can be there in the problem statement, right? That involving while loop, right? While that's the most obvious one, while itself can be there. Other English vocabulary that kind of indicates, that would indicate it's going to be a while loop. During, okay. Anything else? There's a bunch of actually.
As long as.
As long as, all right. There's at least one more. Until, yeah, so they are until, right? Okay. so so take if you see them, then kind of take take notice, okay, there may be a while loop involved, okay. And then there's an improvement. You're going to generalize 3 and 5 to be any two numbers, two positive integers, yet 3 and 5 to be default parameters.